everyone, and welcome back to the Deep Dive. Today we're putting on our sports science detective hats. We're going to try and uncover some hidden secrets about small-sided games.
That's right.
We know they work, generally speaking, but how do they really affect our muscles? You know, down at that deep microscopic level.
Mm-hmm.
What unexpected truths did this study maybe reveal about maximizing our training?
It's a great question.
Think about it. Whether you're an athlete, maybe a coach, or just someone who loves understanding how the human body works, knowing how to optimize your physical activity is, well, it's key.
Absolutely.
We're getting a bit of a shortcut to some seriously important insights today.
Indeed. We're going to dive into a recent study that really sheds light on the, let's say, nuanced ways our muscles respond to different game structures.
Okay.
And this isn't just about general fitness, right? It's about understanding specific muscular activation and fatigue. And that has direct implications for how we design training sessions and maybe even prevent injuries. We'll be discussing a paper that, honestly, it bridges a critical gap in our knowledge.
Okay, let's unpack this then. Our deep dive today is into the article titled Impact of Small-Sided Game Formats on Electromyographic Responses in College Students. The authors were JuanFeng, Alejandro Rodríguez Fernández, Robert Trybulski, Tomasz Grzywacz, Piotr Sawicki, and Filipe Manuel Clemente.
Quite a team.
Yeah, and you can find this published in the Journal of Sports Science and Medicine, Volume 24, pages 729, 738. It was published online December 1st, 2025.
In this study, it investigates how common variations in football training, specifically these small-sided games, or SSGs, affect muscle activation and fatigue.
Okay.
So our mission today is to extract the most important nuggets of knowledge from this research. We'll try to present it with scientific clarity, but, in an accessible, engaging way.
Yeah, get to what it really means.
And really understand what these findings mean for you, the listener.
So many of you listening probably already use small-sided games in your training, or maybe you just play them casually.
Very common, yeah.
But for anyone who might be new to the concept, what exactly are SSGs and why are they so widely used?
Right. Well, SSGs are essentially scaled-down versions of traditional team sports. Think football, usually, especially in this study's context.
Okay.
They're used a lot in training. And they're brilliant because they develop multiple things at once. Physical fitness, technical skills like passing, dribbling, and also tactical understanding.
Sort of replicating game situations.
Exactly. Replicating match-specific scenarios, but in a more controlled environment. Coaches can tweak what they call task constraints.
Like pitch size.
Yeah, things like pitch size, player numbers, maybe specific rules they manipulate these to target specific training responses.
Okay.
For instance, smaller formats, like fewer players, often increase the physiological demands on each individual player, even if the total distance they run might actually be lower.
That makes a lot of sense. We know SSGs are effective for improving things like endurance, VO2 max, and technical skills. But here's where this study gets really interesting, I think. While we've seen performance drops after SSGs like lower jump height or less power output.
Right, acute fatigue.
Yeah, exactly. But the underlying neuromuscular mechanisms, what's happening at the muscle fiber level, that hasn't really been fully explored, especially not with these advanced tools.
Precise.
So this is the gap this study is trying to fill, right? To understand why those performance drops happen.
Exactly. Previous research documented the what's performance drop but the why down at the muscle fiber level. That's been less clear.
Yeah.
And that's where surface electromyography, or SEMG, comes in.
The muscle electricity measurements.
Yeah. It gives us a direct, non-invasive way to look at muscle activation and fatigue. It quantifies both the magnitude and the spectral characteristics, the sort of quality of the electrical signals our muscles produce.
Okay.
Understanding these neuromuscular responses is super crucial for coaches who want to design sessions that really target specific muscle groups and, importantly, manage fatigue effectively.
Okay, let's talk methodology then. How did they actually measure this muscle activation and fatigue? It sounds like some pretty serious science was involved to get this kind of detail.
It absolutely was. So the researchers recruited 60 healthy university students. They were all non-professional soccer players.
Okay.
And they randomly assigned them to 3 groups, 20 in each group. Then they put them through a 5-day SSG training program, all on a standardized artificial turf pitch.
And each group played a different format.
Correct. One group played 1v1, another 3v3, and the third played 6v6. And the training duration, the recovery intervals, even the pitch sizes were meticulously controlled for each format.
Why control all that?
Well, to ensure consistency, right?
Yeah.
And to really isolate the effects of just the player numbers, the format itself.
Gotcha. Can you give us the specifics on those formats? I imagine the details of those constraints, like the pitch size and timings, matter a lot here.
They certainly do. So for the 1v1 format, participants played 8 rounds, just 1 minute each. Yeah, with a 1-minute passive recovery between rounds. And this is on a pretty compact 10 by 20 meter pitch.
Okay.
The 3v3 group played 3 rounds of 4 minutes each, with a longer 3-minute passive recovery interval. Their pitch was a bit bigger, 30 by 15 meters.
Right.
And finally, the 6v6 format. That consisted of 2 6-minute matches, sort of like halves, with a 3-minute halftime break. And their pitch was the largest, 40 by 20 meters.
Okay, so clear differences in duration, recovery, and space.
Exactly. Those variations in player numbers and the corresponding pitch size are the key task constraints coaches often play with. And that's what this study really honed in on.
So they had these students playing these different formats, but how did they actually, peer inside their muscles, see what was happening electrically?
Right. They used surface electromyography, SEMG. This technique uses electrodes placed on the skin to measure the electrical activity of the muscles underneath.
Okay.
They focused on 2 key muscles in the lower limb. The rectus femoris, or RF, exactly, part of the quadriceps, plays a major role in hip flexion and knee extension, the kicking, sprinting.
Right.
The other was the biceps femoris, or BF. That's a key hamstring muscle, crucial for deceleration, powerful hip extension, and that eccentric control, basically, the braking movements.
Got it. And to assess the activation and fatigue, they looked at specific SEMG parameters.
That's right. 2 main ones from these muscles.
And what were those specific parameters? I think getting this clear could really help us understand the results later.
Absolutely. Good point. The first was the root mean square, or RMS. You can think of RMS as how loud your muscle is shouting electrically.
Okay, like the intensity.
Precisely. It reflects the intensity or magnitude of muscle activation. Higher RMS means more muscle activity, more fibers recruited, firing more intensely.
Got it. Loudness equals activation. What was the second one?
The second was the median frequency, or MF. This is calculated using a technique called fast Fourier transform, basically looking at the frequency components of the signal.
Okay, bit more technical.
Yeah, but what's important is that MF is particularly sensitive to fatigue-related shifts. Think about the clarity of that muscle shout we talked about.
Okay.
As a muscle fatigues, its electrical signals slow down, they become a bit fuzzier, less efficient maybe. So decrease in MF on our readings is like a direct red flag that fatigue is setting in.
That analogy actually helps a lot. So it's not just the volume RMS, but the quality or clarity MF of the signal that tells the story of fatigue.
Exactly. You need both to get the full picture.
And they didn't just measure during the games, right? They used specific tests before and after the SSGs.
Correct. Before and immediately after the SSGs each day, participants performed 2 standardized tasks in a controlled lab setting.
What were those?
First was the double leg stance, DLS, balance task. This measures postural stability and, the subtle muscle activation needed just to stand still. Participants stood naturally for 30 seconds.
Okay, a balance test.
Yeah, and the test stopped if they lost balance. The second, after a minute's rest, was the counter movement vertical jump, CMJ task.
A power test.
Exactly, an explosive movement. This was used to reveal muscle activation and fatigue under more dynamic, high-force conditions, kind of like jumping for a header in football. They actually measured jump height with a force platform, too.
That's a really clever way to isolate the effects of the games on different types of muscle function balance versus power. And what's fascinating here, you mentioned this briefly, the researchers also tracked the overall internal load using heart rate and estimated oxygen uptake.
Standard measures, yeah.
But they found no significant differences in those overall physiological measures across the different formats, the 1v1, 3v3, 6v6.
That's right. That was a key finding itself.
Which suggests that while your body might feel a similar overall level of exertion, what's actually happening at the muscle level, the neuromuscular impact, would be very, very different depending on the game.
Precisely. It hints that overall heart rate might not tell the whole story about muscle-specific fatigue.
So what did they find when they looked at those SEMG results, the RMS and the MF?
Well, what's really fascinating here is exactly that point, how distinct the muscular responses were across the different SSG formats, even when that overall physiological effort seemed pretty similar.
Okay.
And this raises that really important question. Are all small-sided games created equal when it comes to specific muscle targeting and the fatigue they induce.
And it sounds like the answer is a resounding no. Let's break down the general findings first, maybe.
Okay, so first, a broad observation. They found that the CMJ tasks, the jumps, consistently triggered significantly greater muscle activation, higher RMS, and also greater fatigue, lower MF compared to the DLS, the balance tasks.
Right.
This held true across all the game formats. And it wasn't just a small difference. The data showed it was statistically significant, which honestly isn't that surprising, right? The jump is way more explosive than just standing still.
Okay, so the jump is always harder on the muscles. That makes sense. But the real interesting part is how these different game formats played out. What did 6v6, the biggest group, show us?
Right, the 6v6 format. This one produced the highest overall muscle activation and the greatest fatigue, particularly in the jump tests afterward.
Okay.
Specifically, the CMJ RMS, or loudness as measure, was highest for 6v6. It also resulted in the greatest fatigue, shown by the lowest CMJ-MF, our clarity measure.
And this was significantly different from the others?
Yes, it was a statistically significant difference for both activation and fatigue when compared directly to the 1v1 format after the games.
Wow. So if you're looking for a serious workout that really pushes your muscles, especially maybe the quads, the rectus femoris, 6v6 seems to be the one.
That's right. The rectus femoris specifically showed its highest activation levels in the 6v6 format post-game.
Okay.
This suggests that these larger-sided games might really potentiate or boost quadriceps recruitment, probably because of the increased running speed, more open space, and the need for longer, faster sprints to cover that larger pitch area.
So if a coach wants to really stimulate explosive strength, maximize quad activation for those powerful, quick movements, 6v6 is the way to go.
Precisely. It seems to offer a significant strength-focused stimulus. Makes it very suitable if your training goal is prioritizing powerful concentric force production, especially in the quads.
Okay, that's clear for 6v6. What about 3v3? Did that one sort of strike a middle ground?
The 3v3 format, yeah, it did seem to show an interesting balance between activation and, let's say, controlled fatigue.
How so?
Well, it produced the peak DLS-MF value. Remember, MF is our clarity or fatigue measure. So higher MF means less fatigue during those balance tasks compared to 1v1.
Okay, better fatigue resistance and balance for 3v3.
Yeah, and it also resulted in higher activation patterns in the biceps femoris, the hamstring muscle, during the jumps, CMJ, but with only moderate declines in MF.
So good hamstring engagement, but not excessive fatigue.
Exactly. It suggests effective hamstring engagement, but with manageable fatigue levels.
So if you're trying to enhance hamstring function, maybe work on that eccentric control, those crucial braking and powerful extension movements, and perhaps minimize injury risk. 3v3 sounds like it could be the sweet spot.
Yes, it definitely appears to be a really good option for those objectives. Given the hamstring's crucial role in deceleration and eccentric control, 3v3 seems to provide appropriate demands without completely overstressing the muscle,
right?
Which makes it potentially beneficial for improving fatigue resistance and control during balance and agility tasks, which translates directly to better movement on the field.
Okay, 6v6 for quad power, 3v3 for balanced hamstring work. What about the solo act, the 1v1? You might think that's the most intense, but the findings had a twist, didn't they?
They did indeed. It's counterintuitive, maybe. While 1v1 obviously involves continuous maximal individual effort.
Yeah, nowhere to hide.
Right. But participants actually showed significantly lower CMJ-RMS values, less activation loudness after the task, compared to both 3v3 and 6v6.
Lower activation after 1v1. Why?
Well, it's not because it was less physically demanding during the game. Quite the opposite. It suggests that the acute neuromuscular fatigue generated by the 1v1 game actually impaired the muscle's ability to recruit fibers afterwards, even during a maximal jump.
Ah, so they were too tired to activate fully?
Pretty much. And the MF values, the clarity, were also consistently lower in 1v1 across both the jump, CMJ, and balanced DLS tasks compared to the other formats. This indicates a really significant fatigue-induced shift towards those fuzzier, slower EMG frequencies.
So when we say 1v1 led to lower muscle activation post-task, we're talking about the muscles basically being, well, too tired to fully fire, even if the person was trying their hardest.
Precisely, it's the latter. The intense, relentless demands of 1v1 seem to induce such profound fatigue that even during a maximal effort like a jump after the game, the nervous system just struggles to recruit and activate those muscle fibers to their full capacity.
Okay.
It's not that the individual isn't trying, but the system is just too fatigued to deliver that peak performance, which shows up as less activation in the measurements. It points to a greater accumulation of, likely, peripheral fatigue within the muscle itself.
Wow, that is a crucial distinction. It might feel super intense during the game, but it comes at a high cost in terms of that post-game fatigue, especially for the hamstrings, it sounds like.
Yes, the biceps femoris experienced the greatest eccentric fatigue in this format, likely due to all the high braking demands and rapid changes of direction inherent in those one-on-one duels.
Okay, I can definitely relate that to feeling wrecked after intense 1v1 drills. So this means 1v1 can be effective, maybe for short-term neural stimulus, but you really need careful load monitoring and specific recovery protocols because of those high neuromuscular demands and that hamstring fatigue risk.
Exactly. It's probably not something you'd want to do daily for extended periods without careful planning and adjustment.
Okay, that makes sense. Now, you mentioned the study looked at this over 5 days. What about the time course? Did things change day to day?
Yes, and connecting this to the bigger picture, looking at the evolution over the 5-day training period, gives us crucial insights into adaptation, or maybe the lack of adaptation, and how cumulative fatigue builds up.
Right, because how the body adapts or fails to adapt over time is often the real story in training, isn't it?
Absolutely. So what did those 5 days reveal about cumulative fatigue?
Yeah.
Well, for the DLS balance task, the RMS values the activation loudness. They actually increased progressively over time in the 3v3 and 6v6 groups, particularly noticeable on days 4 and 5.
Suggesting adaptation.
Yeah, suggesting some positive neuromuscular adaptation, maybe improved motor unit recruitment with that repeated exposure in those formats.
Okay. But what about fatigue, the MF?
Right. The MF values are clarity or fatigue marker.
Mhm.
They decline progressively across the days in all the groups, but the most pronounced decrease was seen in a 1v1 format.
So fatigue built up fastest in 1v1?
It appears so, especially early on between day 1 and day 2, and again on day 3 compared to 3v3. This really points towards cumulative fatigue building up more rapidly and potentially insufficient recovery time in that 1v1 group over the 5 days.
So even if muscle activation seems stable or even improves over time in some formats like 3v3 and 6v6 for balance, fatigue can still be sneakily building up in the background, and it does so most rapidly in the 1v1 format.
Exactly. And for the CMJ task, the jump, the RMS values, stayed relatively stable across the days for all groups, suggesting maybe a plateau and maximal activation capacity after the first day.
Okay.
But the MF values, the fatigue marker, showed persistent differences between the groups throughout the week, though the significant differences were mainly established on day 1. This indicates that the fatigue dynamics, not necessarily the activation capacity, are primarily driving the variability in recovery between the formats.
Interesting.
This mismatch, stable activation but progressive or differing fatigue, really underscores the importance of monitoring both RMS and MF. You need that comprehensive view of training stress and recovery balance rather than just relying on how hard someone feels they worked or even just one EMG measure.
So wrapping this all up, what does this actually mean for the coaches, the athletes, or even just someone trying to optimize their, casual pickup game? This isn't just academic theory, right? There are real-world applications here.
Absolutely. These findings provide a pretty concrete basis for designing more effective and, crucially, more targeted training programs.
Okay, like what?
For example, if your goal is to stimulate explosive strength and really maximize quadriceps activation, the RF muscle,
Over 6v6.
larger formats like 6v6 seem recommended, based on their higher post-SSG RMS responses.
Okay.
If you're focused on enhancing hamstring function, the BF muscle, working on eccentric control while achieving a balanced activation and manageable fatigue.
3v3 is the sweet spot.
Yeah, 3v3 appears optimal, particularly beneficial maybe for improving fatigue resistance and control during balance and agility movements.
Right.
And for high-intensity conditioning. Well, 1v1 is certainly effective for that. But because of the significant neuromuscular fatigue it causes shown by those consistently lower MF values and the impaired post-task recruitment.
Need careful recovery.
Exactly. Specific recovery protocols become absolutely crucial to mitigate injury risk, especially for those hamstrings. You have to manage the load carefully.
And it really highlights that point we touched on earlier. Overall physiological load, like your heart rate or even RPE, perceived exertion, it doesn't always tell the whole story about what's happening locally in specific muscles, does it?
Not at all. Coaches really need to consider multiple assessment tools, potentially including things like SEMG, if available, or at least be aware of these differential effects.
Yeah.
This awareness allows for more individualized recovery strategies. And you can design SSG-based training weeks or microcycles that truly align with your specific performance goals, whether that's improving power, control, or fatigue resistance.
It shows that, yeah, there can be this disconnect between how hard your heart is working and how much specific muscles are fatiguing.
Precisely. Emphasizes the need for a multifaceted approach to monitoring training.
Wow, what an incredibly insightful deep dive into the sort of hidden world of muscle responses during these small-sided games.
It is fascinating stuff.
It really changes how you think about those seemingly simple training games, doesn't it?
Yeah.
Understanding the specific impacts of 1v1, 3v3, and 6v6 on muscle activation and fatigue is such a powerful tool. The big reveal here, I think, isn't just that different games work different muscles, we probably suspected that, it's how they fatigue them, and that what feels most intense, like 1v1, might not be building or fatiguing your muscles in quite the way you expect. Especially that finding about 1v1 potentially impairing muscle recruitment afterwards if you don't manage recovery, that kind of flips some conventional wisdom on its head.
It really does. And it underscores that there's always more to learn, right? That critical thinking, questioning our assumptions, considering different viewpoints, even in something as seemingly straightforward as a training game, it just enriches our understanding.
Definitely.
And the study also, naturally, highlights areas for future research. Things like looking at longer-term adaptations, how this applies across different sports, and maybe the direct influence of these SSG formats on injury risk over extended periods.
Yeah, lots more to explore.
Which suggests maybe a provocative thought for you, our listener, to take away. If simply changing the number of players on a pitch can have such specific, measurable effects deep within our muscles, what other subtle manipulations in our daily activities, our workouts, our recovery routines could be impacting our physical performance or recovery in ways we don't even fully appreciate yet?
Ooh, that's a fantastic thought to ponder. If you're as fascinated by these findings as we are, we definitely encourage you to read the full article by Feng and colleagues in the Journal of Sports Science and Medicine. You can dive even deeper into the data and their discussion.
Well worth the read.
Absolutely. And if you enjoyed this exploration of science and performance, please make sure to follow the Deep Dive channel and turn on those notifications so you don't miss any of our future explorations.